The James Webb Space Telescope is unfolding the universe in the truest sense of the term. Not only has it found galaxies at the edge of the observable universe, it has also shown scientists that the dark ages of the universe, according to our cosmological model, were not really dark. Stars, in fact galaxies, started to form very early in the universe, just after the Big Bang in cosmic timescales. We also found out that black holes existed long before our models predicted them to be. And one of its many amazing discoveries is studying exoplanets. Webb has successfully analyzed chemical compositions of planets millions of light years away from us. That's right. Those small lumpy blobs are light from an actual planet, one almost 10 times the size of Jupiter and almost 400 light years from Earth, known as HIPS 65426b. It orbits a star much larger than our Sun, and is very young. So young, in fact, that it's still warm from the primordial heat of its formation, glowing brightly in infrared light. Those infrared photons traveled directly from another world to reach Webb's magnificent golden honeycomb mirror, creating the images we see. It's incredible that humanity has managed to directly view another planet, a task likened to photographing a firefly buzzing amid a city's lights from hundreds of miles away. Planets are extremely faint compared to the bright stars they orbit, so to view them, we must sift through the starlight to uncover the planets underneath. Astronomers solve this problem by filtering starlight with an item known as a coronagraph, which blocks out the bright central area of the star, and by keeping images steady and crisp with adaptive optics technology. The James Webb Telescope has the distinct advantage of being in space, above Earth's pesky atmosphere, as the air around our planet blurs images and blocks out certain wavelengths of light. The Space Telescope also can resolve details in planetary spectra, around 100 times finer than previous direct imaging instruments on the ground. Webb's first directly imaged planet and first direct spectrum of a planet-sized object are both huge steps forward for direct imaging. And someday, who knows, life might blossom on one of those planets that are yet to form. But we don't want to know about someday. We want to know what is in the now, correct? Yes, the Space Telescope has found a lot of interesting stuff, and it even showed that the universe might be older than we think it is, but we will get to that later. First, let's talk about what we have all been waiting for with bated breath. The search for life elsewhere in the universe. A recent investigation conducted using NASA's James Webb Space Telescope on K2-18b, an exoplanet with a mass 8.6 times that of Earth, has uncovered the presence of carbon-based molecules, including methane and carbon dioxide. This discovery made by Webb contributes to recent studies that suggest K2-18b might be classified as a Hycean exoplanet, one potentially featuring a hydrogen-rich atmosphere and a surface covered by a water ocean. The initial insights into the atmospheric characteristics of this exoplanet within the habitable zone were initially gained through observations made with NASA's Hubble Space Telescope. These observations subsequently led to further research that has reshaped our comprehension of the K2-18b system. K2-18b orbits a cool dwarf star called K2-18, located in the habitable zone and situated 120 light-years away from Earth in the Leo constellation. Exoplanets like K2-18b, falling between the sizes of Earth and Neptune, are unlike any planets found within our solar system. The suggestion that K2-18b could potentially be a Hycean exoplanet is particularly intriguing, as some astronomers believe that such worlds hold promise as environments to search for signs of life on exoplanets. The presence of methane and carbon dioxide, along with the scarcity of ammonia, lends support to the hypothesis that K2-18b could potentially have a water ocean beneath a hydrogen-rich atmosphere. The initial observations by Webb also hinted at the possibility of detecting a molecule known as dimethyl sulfide, or DMS. On Earth, DMS is only produced by living organisms, with the majority of it being emitted by phytoplankton in marine environments. However, the inference of DMS on K2-18b requires further confirmation. Upcoming observations with the Webb telescope should be able to confirm whether DMS is indeed present in significant quantities in the atmosphere of the planet. The research team now plans to conduct follow-up studies using the telescope's MIRI spectrograph, with the hope of validating their findings more conclusively and gaining fresh insights into the environmental conditions of the alien world. Following this finding, NASA stated that their ultimate objective is the identification of life on a habitable exoplanet, a discovery that would revolutionize our understanding of our place in the universe. Now, a lot of things have happened lately, with the U.S. Congress officially holding a public conference for the first time about UFOs and aliens, and David Grush, a whistleblower, admitted that the United States does in fact possess crashed alien spacecraft and non-human entities. Also, Harvard professor Avi Loeb found fragments of an object that crashed into our ocean. He says it is from outside the solar system, and could possibly be alien technology. In both cases, we cannot say with absolute certainty if we have come in contact with anything alien. So, what does NASA have to say? NASA is reportedly preparing for the possibility of discovering alien life as part of its ongoing efforts to explore outer space. Dr. Michelle Thaler, a NASA scientist, recently revealed that the space agency has been hosting top-secret conferences to discuss how they should handle the situation if they do, in fact, find evidence of extraterrestrial beings. During a gathering in New York City, Dr. Thaler disclosed that meetings have been held to address the potential discovery of aliens. She further emphasized her belief that it is only a matter of time until alien life is found, given the vastness of the universe. The $10 billion James Webb Telescope, launched in 2021, is a key component in NASA's search for extraterrestrial life. The telescope's advanced technology and capabilities is allowing scientists to examine distant planets and analyze their potential habitability. In light of this, NASA is taking proactive measures to ensure they are prepared for the momentous discovery of alien life. The classified conferences serve as a platform for scientists and researchers to discuss and develop protocols on how to communicate and interact with any potential alien civilizations. It is believed that the discussions revolve around the ethical and practical considerations of making contact with another intelligent species. The scientists also contemplate the potential impact such a revelation would have on religion, society, and the general public. Although the details of the conferences are kept under wraps, it shows that NASA might have already found evidence of alien life. And, if NASA is discussing and developing protocols on how to communicate and interact with alien civilizations, I mean, come on. What do you think? Is it too early to assume that we have made the first contact? Or, have we just spotted a relatively advanced civilization from afar? Keep in mind that whilst Webb has made many groundbreaking discoveries, NASA is yet to show us what the telescope has discovered in the Proxima Centauri star system, the closest star to our Sun. It is also yet to reveal what the planets in the habitable zone of the TRAPPIST star system have to offer. And while we wait with bated breath for the day when NASA reveals the presence of life beyond our planet, let's talk about how the Webb telescope is pointing towards the actual age of our universe. Okay, picture this. Our universe is not the spry 13.7 billion-year-old entity that we once believed it to be. Instead, it could be a grand 26.7 billion years old. Yes, let that sink in for a moment. This finding, according to a new study by Rajendra Gupta, adjunct professor of physics at the University of Ottawa, fundamentally changes our understanding of the universe, and may solve the puzzle of the impossible early galaxy problem. For years, we've been estimating the age of the universe using two primary methods. First, by calculating the time that has passed since the Big Bang, the colossal explosion believed to have birthed our universe. And second, by studying the oldest stars, based on the redshift of light coming from far-off galaxies. The redshift phenomenon happens when light from an object moving away from us stretches towards the red end of the light spectrum. By measuring this redshift, we've been able to calculate the age of the universe. In 2021, using a model called the Lambda CDM concordance, scientists estimated the universe to be about 13.797 billion years old. But there's a problem. Some stars, like the Methuselah, appear to be older than the universe itself. And that's not all. The James Webb Space Telescope has discovered early galaxies that seem to be far too advanced for their age. These galaxies were around just 300 million years after the Big Bang but had the mass and maturity typically seen in galaxies billions of years old. What's more, they're much smaller than we'd expect, adding another piece to the puzzle. This is where Fritz Zwicky's tired light theory comes into play. According to this theory, the redshift we see might not be due to galaxies moving away from us. Instead, it might be because light loses energy as it travels across the universe. For a long time, this theory conflicted with what we saw in the universe. But according to Gupta, if we let this theory coexist with an expanding universe, we can reinterpret the redshift as a combination of both these phenomena. But Gupta didn't stop there. He also introduced a new idea based on physicist Paul Dirac's hypothesis about coupling constants. These are fundamental physical rules that control how particles interact. According to Dirac, these constants might have changed over time. If we let these constants evolve, then the time for early galaxies to form extends from a few 100 million years to several billion years. That could explain why the galaxies we see are so advanced for their age. Finally, Gupta challenges the traditional interpretation of the cosmological constant. This represents dark energy pushing the universe to expand faster. Instead, he proposes a new constant that accounts for the evolving coupling constants. This change could help us understand why the early galaxies were smaller than expected. It also offers a more accurate picture of the universe. In the words of Gupta, our newly devised model stretches the galaxy formation time by several billion years, making the universe 26.7 billion years old, and not 13.7 as previously estimated. The universe might be much older than we thought, and that could shed light on some of its biggest mysteries. Case in example, the latest findings from the James Webb Space Telescope. It has enabled astronomers to see things that they cannot explain. From the depths of the cosmos, the Webb Telescope has extracted light coming from 44 galaxies that formed during the first 500 years of the universe. According to the standard model of cosmology, the universe is 13.8 billion years old. For stars to form, and then galaxies, only within the first 500 million years, is nothing short of a cosmic marvel that we cannot fully fathom. But wait, the story doesn't end there. The recent data from Webb's observation also found that the deeper you look, the more galaxies you find. Yes, astronomers spent 50 hours peering into the deepest part of the cosmos, and spotted some of the first galaxies ever formed, immediately after the Big Bang. You can also understand their dilemma when they discovered that some of these 40 early galaxies formed only 200 million years after the Big Bang. Yes, galaxies, not stars. It is not rocket science to deduce from there that the stars that formed those galaxies existed much earlier than that. Now, coming to the more fascinating part. Yes, the Superstar Telescope just keeps giving. The data from this observation also revealed that these primordial galaxies emitted a phenomenal amount of energy into space, 10 times more than scientists predicted. To understand it clearly, let's first look at this deep field image captured by Webb's MIRI instrument. This deep field view of the cosmos shows vivid spiral galaxies in the foreground, and a plethora of much older galaxies in the distance. Pretty much all these objects are galaxies. When scientists zoomed in on 3 of the highly redshifted galaxies in the background, they discovered that these galaxies were releasing unexpected amounts of energy. The data also suggests that they would have formed in the first 200 to 500 million years after the Big Bang, when the universe's age was 1 to 5% of today's. The big question here, though, is how did these galaxies emit such a phenomenal amount of energy into space? Scientists find only 2 possible scenarios staring back at them. Black holes, or massive stars, even bigger than the red hypergiant stars, that inhabit the universe today. To find the answer, astronomers have simulated, with advanced computing, how the universe has evolved over billions of years, beginning with the formation of the first stars and galaxies, and eventually creating the essential organic materials for life. But here is the thing. Ironically, they could not find light at the end of the tunnel, because no simulations predicted such extreme emissions of ultraviolet energy. So what might explain it? Rajendra Gupta's model. But scientists are studying his theory, and pretty soon, we will understand the true mystery behind the origin story of the universe. Fancy that? Territory.